ESV Junior, and welcome back to the Engine Performance Expo. Again, with our buddy Ben Strader. Going to do a little bit of advanced technology demonstration here.
Yeah, cut to the good stuff finally, right?
All right, so Ben, tell them what this little thingy-dinky is.
Well, you know, a while back I realized that oftentimes guys will have a component or an engine part or a whole engine failure, and you never really know why. And we've just kind of...
The mysteries.
It's the mystery, like, I don't know, that's just racing, engine failed, I don't know why.
Yep.
And I learned...
Happens all day, every day.
Yeah. You know, I learned from working with some of the guys at the higher levels that it wasn't so much that we were just unlucky, is that we weren't checking things well enough. We weren't looking close enough either before we assembled stuff or after we'd run it to know, like, can I run that part again? What's the life expectancy? And so I went out and started researching, like, what are you guys doing? And it turned out a lot of what they were doing was microscopic inspection.
Yes.
So, you know, I had to look at, like, what's the sort of NASCAR level budget and what's the Ben level budget.
Yeah.
And then I had to go see my banker and see if we could land somewhere in the middle. And we ended up with this is called a Vision Engineering Evo Scan.
Okay.
And what's cool about this thing is it is a microscope lens, but it's also a digital camera. So that does a couple of things for us. First of all, it lets us really zoom in on a part.
Right.
But because it's a digital camera, I can be looking at it live. And displaying it on my screen, so like, for example, you and me or a group of my students, we could look at the same time. So that was one of my main reasons for getting it. But
that's
also,
really nice.
Yeah, super nice. I mean, it's live. I can put my hand in there and move around. Another feature that I really wanted was I wanted to be able to inspect parts, let's say for a customer who's far away. My buddy Robbie Blankenship, I built his stuff. We're working on it here today. He lives all the way in Florida. I'm in Arizona. It's hard for me to get the point across sometimes.
Right.
So with this, I can zoom in and I can actually take a picture and save it to a USB drive. Then I can email it to him.
That's super cool.
Yeah.
I mean, at Total Seal, we have microscopes like this, but it's not like this. So we have an inspector. He looks at the rings, checks them all out, makes sure, okay, yeah, these are all good. And back just not only new rings, but used rings from customers. Like, hey, we want to know what's going on. We can do that, but not like this, where you can actually take that picture and send it off, and then everybody in the room can come in and say, wow, I can see that's a problem.
A picture's worth 1,000 words.
Well, all right, so I got to cut the chase. So go ahead and show us the part.
The part,
right? Because the first time I saw this, I was like, I get it. I totally get why every penny of that thing is worth it.
And it saved me, you know, 50 or 100 times the cost of the machine in things that I caught that didn't fail.
Right.
But this one's my favorite. I'm going to walk over here and show you guys. This is just a straight up regular old GM like LS valve lock. You know, you're all familiar with them. I'll show you the other side of it. I was working on the Spintron one day, and nothing was wrong. I was just doing regular old maintenance. You know, we do a few runs, like a dyno pull, whatever. You know, you do a couple runs, you take the valve covers off, and you lash everything. Yeah. And oftentimes, when we're doing that, we'll take a spring or two off, put them on the spring tester, and pull it, and make sure they still got load. And
yes, that's a totally normal thing to do, especially with the RPM that you're turning.
Right.
In those engines, that's a very practical, smart thing to do.
I thought so. So I'm looking at this stuff, and I went to put it back together, and I don't know why, but something just in my gut didn't seem right, feel right, smell right, taste right. I don't know what happened. But in my brain, something clicked and said, look at that again. So I looked at the retainer, and I looked at the locks, and, you know, I'm looking at this lock, and I'll let you look at it. I know you've seen it before, too. But, man, by the naked eye, you can't tell that a lot is wrong with that lock. I'll tell you, there's a little bit of a double kind of groove on the bead side, on the inside. But frankly, it's not that bad.
It just looks like a used lock.
It's not
that bad. It's what it is. It's like, I've seen these out of the engines. It's just a used lock. It's normal.
So I decided...
Until you put it under here.
Yeah, so I decided, you know, just to be safe, I'll walk over and I'll stick it under the microscope here. So, you know, you stick it in there.
You can see, right? It doesn't... You can't really see. You know, he said there's a little bit of something there. But it's like, oh, it could be dirt or whatever.
Yeah, and at this point, we know what to look for, right? So I can see where it's at now, but back then I couldn't see it.
Right, yeah. If we hadn't pointed anything out, no one would probably even know.
That's right. So I stick it in here, now you can see it's live. Now this is at 5 times magnification, so not a lot going on there, but I can zoom in a lot here. So let's go into about 40 or 50 times magnification. So now we're 50 times magnified. And when I move in here, I think you'll be able to see, oh my goodness, right away. Hopefully you guys can see this. There is a crack that runs all the way along this outer edge of the lock.
That would be the San Andreas fault, I think.
That would be the San Andreas fault. Now if I zoom out and flip it over, we'll see that crack again there. In fact, you can almost already see it now. You can see it's cracked here, and you can see it's cracked here. You really cannot see that with the naked eye.
It's almost all the way through there.
It is.
So
in fact,
like maybe one more pull, and it's done.
It was going to drop a valve. Yep.
Yeah.
So here you can see in the bead, as I zoom in there, you can see it's cracked.
Wow.
Multiple places it's cracked all the way through, which I only found upon magnified inspection, right? So, and we can get really silly and go in here, you know, here's 150 times, and now you can really see those cracks. But we tend to use this to catch all kinds of problems like this before they become catastrophic disasters. This one I just got lucky on. I have since then updated our procedures and our routine, so now we run so many runs and we take it apart and we just have a look at a couple just to make sure, because I caught that by accident. Now I don't want to be catching stuff by accident, so we go to the next thing and the next thing, and eventually we get, you know, we check things off our list that we just don't have as many random failures anymore that we're not sure what happened. Now when something happens, we usually can look in here and find the culprit on something like that. So next time that thing drops a valve, which is hopefully never.
Yeah, hopefully not anytime soon, right?
We'll know that's a good key indicator place to look. So this is one of my favorite training tools now that I keep in the shop. But you know, we look at a lot of stuff after we run the engine. Here's our ring out of that Robbie's 400 inch. This is a 400 cubic inch naturally aspirated small block Ford. It uses a ring.
And that is a piston ring.
This is a here. You show. You're the piston ring guy. Tell me.
This actually is a piston ring.
Yeah, that's a 20
it's
by
okay,
80.
right? So it's 020 by 80.
020 by 80. So it's 20 axial and 80 radial. You can take it up there and show them real close if
there
you
we
want.
go.
So that is a 20 thousandths of an inch thick by 80 thousandths radial. Very, very, very small ring.
Can I make a comment real quick?
Please do. Yeah.
This is a seal.
That's it.
It's not a wrist pin.
It's a gasket.
It's not a structural component.
Yep.
It's a gasket. This is definitely not a 5/64th, 3/16th ring package. Just letting you know. I know they still sell them, but this is a piston ring. That other thing is a dinosaur. Anyway, I had to say.
These are definitely on the rare side of what guys.
Yeah, they are.
I mean, you're talking about 20 thousandths of an inch thick. This is our top. This is our combustion seal ring. But we do that to lower the friction and the drag in the engine. And then it's got specialized coatings. This one's
titanium
nitride coating, and you can tell because it's got that gold C72 coating. The
same type of rings we ran at Joe Gibbs Racing.
Yeah, this is straight out of like an expo shop.
Yeah.
We just happen to be using them on our drag race stuff. And it's been really great for us, right?
Yeah, it's
and so there are things that we measure before and after. So before we set our ring gaps, we get all our clearances, and we measure the free gap. You guys may or may not know what free gap is, but this thing's a spring, right? So I push it in and it recoils. So the free gap there is that amount of gap that it has. If I lay it on the table here and measure that distance that the gap is open now. So if I get the ring too hot, or get my tune-up out of control, and my free gap closes up, it relaxes because this spring loses its tension, right? So we typically will measure that free gap before, write it all down, and then in our kind of tear down process, then we can check them and make sure that we're okay there. So good thing for you guys to be looking at. But besides free gap, we want to see what like the surface of the ring looks like. Sometimes we'll look at the face of the ring. And one thing that I've learned from doing this is just how amazingly tough these rings are, especially some of these really hard tie nitride coatings, man. It's totally okay. If your free gap's good, everything else good, totally okay to rerun this ring after we take it off the off the dyno or make some runs down the track. If the ring's not hurt, the ring's not hurt. We can rehome that thing, stick these right back in.
That's the real benefit of a steel ring with the titanium nitride coating.
Sure.
It's a hard coating, hard material. It's durable. It's not going to wear out. It's not a soft molly type ring where they can be beaten up by heat and load easily. It's a very durable ring. That's why it lasts.
We usually wear out the cylinder bore before we wear out the rings. As long as you don't do anything to hurt them, But
you can check and see. You can see if there's any kind of damage to it.
Well, tell you what, let's take a look.
Debris or anything has gone through there and damaged it in any way.
This is a ring that's straight out of that, so I'm going to move it over here, and we'll zoom in a little bit. So I got my crosshairs there, and we'll zoom in and see what we get. So we're looking at this at about 46 times magnification, which is about all it really takes, So what I'm looking for is you can actually see the wear. You can see where it's lighter on one side and darker on the other side, or it's been rubbing on that piston.
One's in the ring groove and one's in the cylinder.
One's in the cylinder wall, that's right. So what I typically look for is I'll roll this thing around And it takes a little bit of practice to keep it in your view here, but I'll kind of go all the way around. And I'm looking for any nicks, any scrapes, any cuts, any deposits from the piston.
Yes.
So we call that micro welding, where if you get the piston hot enough and that aluminum starts to melt, it just spurts and sputters right off from the piston and transfers to the ring. So that's the kind of stuff I'm looking for, because if it's on my ring, then my ring's not going to sit totally flat in the groove, and I'm not going to have good ring seal. But as you can see, this one, even only being 20 thousandths of an inch thick, looks plenty good for after going on the dyno, going down the track. You know, this is still in pretty good shape. So short of having anything we measure wrong with the free gaps, I'm probably going to rerun this ring. It looks okay. And we'll go through the entire set of rings that way and inspect everything. And by the way, I look at all my brand new ones too, because here's the thing. You look at a part, and one of the problems that I had when I first got the microscope is it made me want to take every part in the shop and throw it in the trash.
You know the dyno is a heartbreaker. This thing will really kill you.
This will hurt your feelings, man. You think you have something that's good, and you look at it a little too closely, and oh man, you just want to throw up. So, but what I had to do is I had to balance that ability to look way, way deep at the microscopic level with, well, okay, but what's actually acceptable, and start looking at new parts and go, okay, here's a known good new part. They look like this. So what I'm looking for is, okay, this doesn't look so bad all of a sudden.
It's a comparison.
It's a comparison tool, right? So, I mean, I can, you know, if a guy walks into my shop, I can sell you just about any part in your engine if I zoom in close enough. You'll want
going away is junk.
That's right. You'll want a new one. So we did have to kind of learn how to use it and be careful with that. So I'll zoom back out here. And I'll talk a little bit about, like, for example, here's a valve. This is a titanium hollow stem, you know, 310 stem. This is 2300, I think, or 2320. This came out of the little small block Ford engine. And this one's been hurt a little bit. It's got a little nick down here on the edge of it, so it won't get rerun. But typically what we would do is, if we decide, before we decide to reuse a valve, we'll typically inspect them in the microscope. So I'm looking for a couple things. I'm going to be looking at the transition between my valve margin and my seat. Right. I'm going to go all the way around the seat to make sure there's no deposits, nothing on the seat, nothing taken off the seat that's on the head. And then for a moly-coated valve, so a lot of your valves are moly-coated, right? And what that means is they'll grind the valve, then they'll cut the valve undersized, and then they'll sputter and spray on a moly coating. So
now talk about why. Tell them why. Because we talked about moly a minute ago with rings. Yep. So now we're talking about moly again with valves. What's the common thread here?
Well, moly's a great material because it's very porous, and the porosity holds pockets of oil. So think about your valve in that guide sliding up and down. There's not a lot of clearance between the guide and the valve. And you don't have a lot of oil flowing through the guide, hopefully.
Yeah, we hope not.
So the moly is a great material then to put on a valve stem and make that
hold that oil there.
Yeah,
so you have lubrication where you need it.
That's right. But we don't coat the entire valve with moly. Typically, the moly will start exactly about the bottom of my guide. So let's say I put this in the head, and my guide's about here. I would start my moly coating here, so that's where it'll be undercut the valve, 6, 7, 8 thousandths, something like that. Spray the moly on, comes up to the top to just a little bit under where your valve lock will be, and then it'll go back, and then there'll typically be some other coating like CRN or DLC or something like that on your titanium valves like this. So, so let's take a look real quick. I'll throw it in here, show you another part of our inspection process. So I'm going to roll it around to a part that isn't killed on this valve so you get a better idea of what I'm talking about. And then we'll zoom in here, and we'll, let's see here, let's roll it out to where we can see what's going on. There we go. So this part that you see here is the valve margin. And then just above it, this part here is our seat. So you might have a 45, a 50, a 55 degree seat. If it's an exhaust valve, you might have, who knows, even more. But what I'm looking for is a sharp edge transition between my valve margin and my valve seat, first of all. So as I roll the valve around in my V-blocks here, I'm going to be looking for that. And I'm also going to be looking for any material that may be deposited onto or taken off of the seat proper. So again,
that's the area that's actually doing the sealing.
That's what's actually closing the door on the port and sealing against the cylinder head. So as much care as you guys put into your valve jobs in the head, we needed to put the same care into the valve itself so that it's two smooth surfaces there. So let's roll around. We'll have a look here. You can see a nice sharp edge transition there. Nothing's on my seat as I roll around. My seat width is...
Oops, there's a bad spot.
So now you can see where that one, like it got tagged right there. So this is a no-go. That one's rejected. We won't be using that again. But on a normal valve, you can see there's some material. There's a good example right there of material transfer. This is most likely some material here that got smashed and broken off and then crushed between the seat. But that's what I don't want to see because that's not going to seal. Right? But assuming it was okay, we'd come all the way around and we'd either reject it or we would put it back in and say, okay, that's good. It passed that part of my test. The next thing I'm going to do is I'm going to move up the stem here to, I'll zoom out a little bit so we can see where we're at, to about where the transition area is between my moly and my regular titanium section of the valve there. So let me zoom.
So what you'll see here is you're going to have one part that is the CRN coating below the moly section. The moly section is there for the part that goes in the valve stem, and you can see it right there. Really clear.
So this is, you can actually see the marks from the grinder, you know, where they were doing that radially. And then here where it changes, that's where the moly coating actually begins on the valve. So what I'm looking for here is any cracks or chips in the moly, because that moly is only 6 or 8 thousandths of an inch thick. So any amount of stress on the valve stem, bending or flexing, will tend to want to crack and break that moly. In fact, I'll show you one here. That's an example of one that's chipped off. But mostly what we find from spintron and dyno work is that when we have the valve hitting the seat and bouncing off, because of the clearance between the valve stem and the guide, it generally will come back and doesn't exactly hit square on the seat again when it closes. So if it's coming back and hitting my seat at an angle, it wants to, it wants to try to bend this valve. And that moly, as good as it is in terms of porosity, it's not very good in bending. It's hard and brittle, so it will chip off. So what I'm looking for here at my transition point as I roll the valve around, chips, cracks, or breaks in the moly, right? So if I zoom in here really good, you'll see what we mean about the porosity of that moly here. Let me get you a good picture. You can actually see a bunch of tiny, it looks like pinholes in the moly there. That's by design. That's there to retain oil, trap it in there, and carry it up and down that guide. So,
which is one reason why moly-faced rings are easy to break in.
That's right.
And you don't have, and it's not as critical in terms of honing to make a moly-faced ring work.
That's right.
But it won't last as long. The CRN one, our C33 coating is like a CRN type coating. It lasts a lot longer, but your surface finish has got to be better to hold the oil. So it's all about, it's a trade-off, right? Which is why in this application they are using 2 different coatings on the same valve, is because they want the one benefit of the coating, the porosity, to hold oil in the stem section or the seal section. Guide section.
There you go.
But then below that, where you need to keep it clean and everything else, then you're back to the CRN. Now what we got up here, this is the valve lock area.
Now we're looking at the valve lock area. So again, we're looking for that transition between where the moly stops and where the grinding, and I'm looking for cracks and stuff. A lot of times you'll see this material here, which is a little bit of scuffing, scraping, and like maybe even deposited material. And what that typically is when the spring is in surge and a little bit out of control, the locks can squiggle around and move in there. When that becomes very severe, we start to see our moly cracking and chipping up here. So it tells us a little bit about how to diagnose the problem. If I'm seeing my moly chipping at the top of the valve, it's more going to be a problem with spring surge, installed height, distance to coil bind, that kind of stuff. Whereas when it's chipping at the bottom, then it's typically going to be like a load or a frequency issue where the valve's bouncing off the seat. Either way, we got to fix it. But we want to find it before it's a problem. So this isn't really severe, but it's starting to tell us a little bit of movements happening there.
Essentially, that's fretting from the keeper.
That's right, from the bottom of the locker keeper as it bounces around in there. But again, what we're looking for is cracks, nicks, breaks, any deposited transfer of material in here in the groove, rounded edges or crushed edges, stuff like that. This valve, other than the fact that it got smacked on the bottom, would have probably been okay for us to try again in a short-term engine. Maybe not in a 500-mile NASCAR engine, but for any kind of drag race kind of stuff or low-intensity workout, I would totally run that again. So let's take a look at one where the moly is actually cracked up.
Now check this one out. This was really good.
All right, so I'll zoom back out here. And this one came out of one of my engines that we were testing that had severe valve bounce, which is a direct indicator of lack of control.
Don't even need a microscope for that one.
Don't even need a microscope, So, but all the same, since we got one, we might as well use it, right? We'll zoom up in here and we'll get about 50 times magnification. So now what you can see is very clearly this perfectly straight line. That's where the grinding stopped. And where they were spraying that moly on. And you can see that, I'll zoom out just a little there for you can see. This is where that moly cracked and broke off. as the valve was hitting the seat and bouncing off the seat, and then it doesn't hit square when it comes back on. So it tends to like bend and kind of want to oil can the valve there. But that's a great indicator of post-run inspection that we might look for in a valve stem, especially a titanium where it's got a moly coating. If you're running a stainless or an Inconel solid valve, then you're going to be looking at other stuff. But if you're running titanium valves, this is something we want to be aware of.
It's just a great example of how you can utilize this tool to see the things that you can't see with your eye to prevent those, well, that's just racing moments.
Well, I don't know, it just failed. It just
because all those just racing moments always hit your wallet.
Exactly.
Always hit your wallet.
Yeah.
So yeah, you can save yourself some pain with this.
So we've looked at, what have we looked at here? We looked at some rings.
Let's do some rings, the keepers
and valves.
Let's do this next one, right? So, bearing, out of the box bearings.
Yeah, so let's talk about that. You know, obviously we all know that like cleanliness is key.
It's next to godliness, so you have to.
Yeah, cleanliness next to godliness, it's key to having good engines. But how many of you guys out there have ever had a brand new engine that you painstakingly cleaned and took care of? Mm-hmm. You ran the thing on the dyno, mm-hmm. you take it apart to look at it, it's got only dyno time on it, but yet the bearings are scratched and stuff, and they have those vertical, not vertical, but those, you know,
radial moves with the rotation of the engine.
We've all seen it. We just go, man, I swear I had this thing clean.
Right.
Well, so we'll typically take them apart, and we want to look at that kind of stuff too. So I'm going to stick this bearing in here. This is just a regular old, this is like a stock Chevy LSLT aluminum type bearing. I'll back out here a little bit. And so the first thing, I don't know how well you guys can see this, but it's sensitive enough that I can still see the marks from the dial indicator that we had when we clamped it in there and put it in there. We're checking the diameter of the rod. So that gives you an idea of just how soft that overlaid material is, the babbitt and the tin. Very, very soft material. So you do have to be careful when you're quote unquote cleaning those things, right?
Oh yeah, because look how deep those are.
Yeah, I mean, doesn't make the engine blow up. No. It's not going to ruin your day.
It's just fine. It hasn't even worn away yet.
That's right. But for all the effort and work that we put in these engines, we want to be careful with that kind of stuff, right? But so often we go and we take our parts and we put them in the solvent tank and we clean them up and we dry them off and go, okay, it's ready to go together, you know. And so often what I find is I'm disappointed because I take my parts before I put them in the engine, I stick them on the machine here and I'm like, oh my gosh, that is not ready to go together. Let me give you a great example of that. Now, this is indicative of coated bearings. You guys probably out there using a lot of coated bearings. What I have here is a brand new box, and it doesn't matter whose brand. They all have this this type of issue. But this is a rod bearing that's still in the plastic, right?
Yep, so right there.
You know, no smoke and mirrors, no magic here. I'm going to cut this open, and we're going to inspect this brand new bearing. As it came just out of the box. So.
Yeah, remember too, the coating is applied after the bearing's made.
That's right.
So in fairness, right, it's after the bearing has been
they make them, they deeper them, they clean them.
Coating bearings are a good thing.
Absolutely.
It is a dry film lubricant. Yep. It's great for startup. I mean, startup's the worst time in your engine for wear. So anything you can do to reduce that is a good thing. So we're definitely pro coated bearings. Anything you see here, know that we're not dogging anybody out on bearings.
Special brand.
This is just saying, hey, something we noticed.
Yeah. So here's a brand new rod bearing. I just took it out of the plastic. It's clean. You know, most of us would probably take at a minimum our fingers or a newspaper, maybe a piece of cloth, and we'd just kind of wipe it off. Here, you inspect it. My
looks good.
There. Looks pretty good, right?
Yeah.
So what I like to do is take my new parts before I put them in the engine and reference what should it look like, right? So I'll go around here, zoom in. I don't need a ton of magnification. 15, 20, 30 power, something like that's all you need. There's 20, 27. I'll even back out a little because I think if you look here, what I'm looking for again is deposits, scratches, nicks, burrs, stuff like that, right? So I look in here in the tang. That's a big place for them, especially on the back of the tang. A lot of people miss this. Because if you get some junk on the back of this tang, then what it's going to do is it's going to hold the bearing up when you put it in the saddle, and you're going to have a high spot and you're going to have less clearance there, right? So I'm looking for that kind of stuff. But I noticed this one day. I don't know how well you guys can see this, but this one actually isn't really even that bad.
That's the best looking one we've seen, the ones we checked earlier.
Yeah, this was straight out of the package. But look at all the junk that's in here in the oil hole. Now what that is that's flakes of coating, right? But boy, if you saw that, you would have a heart attack and not want to put that in the engine.
And the thing is, the oil is not flowing that way. It's flowing this way. Back to where are those radial scratches from?
From the bearing itself.
Yeah.
Yeah. So you did all this work.
It didn't hurt anything, but you can see it.
Yeah, it's not going to blow up the engine, but
No.
we always wonder, why doesn't my stuff look good? Well, we're not getting them clean enough. That's the bottom line. So typically what I'll do is I'll go in here with a piece of soft, cloth, newspaper or something, and I might take a little tool or something. You can use whatever you want here, just nothing really, really harsh, a little flexible brush, and I'll kind of come in from the back side, and I'll go in there and just kind of get all the junk out of that hole.
Just clean it up a little bit.
Just a little bit.
It's essentially deburring it.
Deep, yeah. And then I'll go back in and I'll look at it again and go, okay, that looks a lot better. There's just a little piece of
Fuzz from the thing.
fuzz in there, yeah. And okay, now I'm feeling a lot better about that.
Yeah.
So that's just an example of, man, we think we have clean parts, we put them in the engine, we run it, it doesn't blow up, but we take it apart, it doesn't look that good. A lot of times it's just gunk, dirt, debris, your coatings, whatever, getting mixed around in the engine. Until I had this equipment, I didn't know that, right? And I know it's tough. You can't expect everybody to run out and buy a $10 or $15 or $20,000 microscope, but even a cheap microscope that maybe costs a couple $100 at the hobby store will find stuff that you would not believe that you've been putting into your engines. So one last one. Sometimes I'll use it to do stuff like this. I'll take a spark plug that's been ran and I'll put it in the bandsaw and just cut the threads off so you can see it, And then it's interesting because you'll go, well, it doesn't look too bad. I know I had a little bit of stuff going on the dyno with my tune-up before I really got it all figured out or whatever. But I don't know how well you guys will be able to see this. But for example...
I can see that North Star already.
Yeah. So here is a great example of an engine that had some detonation, and it's actually got deposits of aluminum, which are part of the piston, embedded in the porcelain of the spark plug.
It's crazy, yeah.
And you cannot see that with your naked eye. You just can't.
Yeah, you couldn't see that even
with a what do you call it, like a magnifying glass or whatever. So hopefully this is a little bit of insight for you guys into a little bit of a higher level of engine inspection and investigation. But we typically look at all of our brand new parts as we're measuring and qualifying them. Then we build the engine, and then when we take the engine apart to disassemble it, we do that whole, we call it reverse blueprinting. And we're checking everything. And what I've found for us is it has dramatically reduced the amount of failures that we have. Now when something fails, it's usually my fault because I screwed it up rather than just some random, I don't know, I guess the part just failed. But I find more often than not, the parts that the manufacturers are out there building are of extremely high quality.
Yep.
We are just, as engine builders, mistreating them and not giving them a fair shake. So hopefully that gives you guys some insight and improves your program a little bit and tells you a little bit about some things you could be looking for.
Well, one thing about this is really cool is, like you said, it's the amount of information you learn on the back side.
Absolutely.
It's that comparison between what it is on the front side, what it is on the back side. The more you learn, the more you know.
Absolutely.
And that knowledge is power.
Yeah, absolutely. We talk about the difference between information and knowing and knowledge all the time. And so just having a bunch of stuff in a book somewhere sitting up in your bookshelf doesn't help you if you're not applying it in real life every day. So hopefully this is the kind of information that through explanation gets transferred to your knowledge that you can implement in your program.
Thanks for watching.
See you next time.
Engine Performance Expo. What a day it has been. Everybody out there watching, we've got a whole scene live here at the location lake. It has been amazing. And we've got Mark Campbell from Edelbrock joining us now in the studio. Mark, before we get into our bit, what's it like out there, right? What a great meeting of the minds.
Absolutely. I mean, sitting out there talking to everybody, I mean, it's amazing to be able to be around so many talented, smart people, and the stories are probably the best part. I mean, you hear some of the old stories about racing and when they were, bending the rules a little bit.
They clam up when they get in here, right? Out there, they're really liberal with the storytelling out there. They get in here, they clam up a little bit.
Well, what they don't know is that we actually have secret microphones hidden in all the tables. And so, sorry guys, we got you.
Exactly.
Maybe.
Or not.
or not. But for next time, we should
probably be a good idea.
Right. So Mark, obviously working for one of the legendary manufacturers in high performance. First of all, that's got to be cool right on its surface.
Absolutely. I mean, Edelbrock obviously been around since 1938 and really one of the first companies to really make speed parts. So yeah, it's a pretty exciting company to work for. The merger obviously between Edelbrock and Comp Cams happened a little while ago here, so that's kind of just made it even more exciting. And we just have so many cool parts that we get to make, and I mean, we're all just gearheads and love this stuff. So it's so easy and just so much fun.
Well, as a Pontiac guy, right? Like nobody made anything, right? And years ago. Now everybody makes everything. Right? It's a different universe. But the first to like decide, well, all right, we'll do some cylinder heads for you guys. Was Edelbrock, and that was a big deal.
Absolutely. I mean, that was one of the things that I think Vic Senior and Junior always wanted to do, was make sure that everybody had speed parts. And I mean, still to this day, that's the way we look at it. We want to make stuff that just people can enjoy and have fun, make their cars a little faster, and just love what they do.
But we're also in a new era of high performance, and so things have got to evolve. What always worked isn't good enough anymore.
Absolutely. There's always new and better, and you learn what works and what doesn't work, and you come up with new things all the time. So it's
you can make
exciting.
a carburetor new.
Absolutely, you can.
There's room for improvement still.
Yeah, I mean, some people look at it and go, oh, geez, it looks like other stuff that's out there. And yeah, sure it does, because there's only so many ways you can skin a cat when it comes to what something looks like.
Right.
I mean, it's incredible what we've done with this carburetor on the inside. There's so many adjustments on this thing, as we were kind of just talking before. I mean, there's 5 different emulsion bleeds inside the carburetor. There's a whole bunch of air bleeds on the top of this thing.
I was carrying it over. I'm like, wait, that's a lot.
Yeah. You just look at it and go, oh, it's a carburetor. But when you really start talking about the features, I mean, I could probably talk for 3 hours on all the features on this carburetor, but just neat stuff.
Well,
absolutely.
The one thing that's right here in front of us, they can see on their side too.
Yeah.
Talk about the idle adjustment.
Absolutely. So no longer do you have to adjust the idle the old school way by actually moving the blades.
Right.
We'll actually set the blades in the right position so that it works with the idle transfer slot and everything like that. And you basically are going to make all the adjustments with these 2 screws on the side of the carburetor to adjust basically it adjusts airflow in and out of the carburetor, so it'll bring the idle speed up or down. So kind of a different way to do it, and you can do it with the air cleaner on, because they're still very accessible from the side. So we've tried to think of all the little things that make it easy.
What is the name of this series of carburetors?
So it is a VRS 4150 series carburetor.
Okay.
The cool part about this, though, 4150 being in the name like that, it does fit a 4150 manifold, but it also fits a 4500 or a Dominator series manifold as well.
Okay.
It's got the dual bolt pattern on the bottom. It's a 1-piece main body on the bottom, so it's very rigid and strong. So if you over tighten those bolts a little bit, you don't break the base plate off.
No one ever does that. No one ever does that.
Exactly. But yeah, really unique design, and like I said, it's got so many features packed in.
Well, like on the camera side, they can see.
Yeah.
You actually have a little boss built in there for throttle position sensor.
Yep. Absolutely. Just 2 screws, you take the plate off, you bolt a standard GM TPS onto it. Whether you're racing, of course, lots of guys like to data log that.
Exactly.
Or if it's going on a street car and you got an electronic overdrive transmission, just plug right into it, and then you got the TPS signal for the transmission so that it can function properly.
That's just smart.
So just try to think of all the little things.
Again, little drain plugs and stuff.
Well, the evolution of everything, right? Like, what did we do? What did we do wrong? What can we do better? Let's redesign from scratch. And not everything, as big as fuel injection is, not everybody can, not everybody wants to, but they want to have modern technology, like a street cruiser or whatever it is. Boom, carburetor. It works.
Well, and that's the key, is that, I mean, I love fuel injection. I have a race car that's got fuel injection on it, but I'll tell you what, this carburetor is about the next best thing to EFI that you can get.
There you go.
It's pretty neat, yeah.
Well, Mark, thank you very much. Appreciate it.
Absolutely.
Back out into the jungle here at Straub Technologies to gain a couple more stories. And we're going to throw it back to a next video as we continue to build our engine. Lake measuring. Very important.
Measuring is huge. We're going to have actually a roundtable later on that specific topic. But right now, we're going to go to QMP Racing Engines in Chatsworth, California, with the man, Brad Lagman, is going to show us his new tool he uses to measuring pistons. The MC1 coming right at you.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today.
They told us, don't start cars. We are not going to listen.